Welcome back, critical thinkers. Today's TEK is G4B. Identify and determine the validity of the converse, inverse, and contrapositive of a conditional statement, and recognize the connection between a biconditional statement and a true conditional statement with a true converse. Now, the focus of this video is to determine truth values of negations, conjunctions, and disjunctions. Our learning objective is to determine the truth values of negations, conjunctions, and disjunctions. And you will know you have mastered this objective when you can actually take a truth table and fill it out correctly. Every skill that you learn in this video is going to make you a stronger thinker and a better problem solver. Now, I know you can do this, so let's turn your practice time into your superpower. Clarity comes from speaking the same language, using the same words, and knowing what those words mean. So our first definition that we're going to look at is the definition of a statement. A statement is a sentence that is either true or false. Now, we represent statements by lowercase letters like P, Q, R, S, T. So it could be any lowercase letter, but we use that letter to signify an entire, basically, sentence. Now, a truth value of a statement is whether that statement is either true, T, or false, F. So an example would be, I have statement P right here, and P reads, a trapezoid is a quadrilateral. Simple statement. Now, we look at that and we go, what's the truth value of that? Well, it's true. A trapezoid is a four-sided figure, therefore it is a quadrilateral. Now we're going to move on to this concept of negation, and that means doing the opposite. So if I negate something, the symbol that I use is right here. It's this little squiggly line. It looks like this. It's a squiggly line. Now, negation means the opposite meaning and opposite truth value. So for example, if I take my statement up here, which is a trapezoid is a quadrilateral, what happens is if I put that little squiggly line in front of the letter that represents it, so it means not P, then that transforms the statement into a trapezoid is not a quadrilateral. Well, we still know that a quadrilateral has four sides. A trapezoid has four sides. So therefore, a trapezoid is a quadrilateral, which means the truth value of this statement, the truth value of the negation, is false. We next need to look at the concept of a compound statement. So a compound statement is two or more statements joined together by the words and or. So whenever you think of a compound statement, the words and or need to come to mind. So now I have two statements. I have statement P and statement Q. Statement P is a triangle is a polygon. Statement Q is a triangle is convex. So if I want to form what we call a conjunction is formed by the word and. A disjunction is formed by the word or. Now there's a symbol that goes with and a symbol that goes with or. The and symbol is like an upside down V, or the way that I like to remember it is, it looks like the outer portion of a capital A. So if I did this, I would have my first letter of the word and. So I remember that the upside down V is and then the V is or. So the way I write this would be statement P and statement Q, or just plain P and Q. Now, if I'm looking at the disjunction, using this symbol, it would be P or Q. And that's the way it's read, P or Q. Here, it's P and Q. So if I'm looking at this and I translate it back up to the original statements that we have, it would be a triangle is a polygon and a triangle is convex. Another way of looking at this, if we use the or for our compound statement, would be a triangle is a polygon or a triangle is convex. And so that's using the disjunction instead of the conjunction. Now, whenever you have a conjunction, this little statement down here needs to be memorized. You need two truths for a conjunction to be true. Two truths, right here, two truths for a conjunction to be true. And you need one true for a disjunction to be true. Take a look at this. If you're going to write something down, this needs to be written down right here. You need to know this. You have to have two truths in a conjunction in order for that compound statement to be true. Now, moving over to our disjunction, you only need one true for a disjunction to be true. Only one true is needed for an or statement. So looking at these ideas in regard to a compound statement, we have two, a conjunction and a disjunction. We use the words and or to connect them. This is the symbol for and, this is the symbol for or. It takes two truths to make a conjunction true. It only takes one true to make a disjunction true. Moving on to the topic of a truth table, we have the definition is a table used to determine the truth values of negations and compound statements. There are two compound statements. We have conjunctions and we also have disjunctions. So whenever we do this, we build a table. So let's look at negation first. I have one statement and that statement is P, okay? So if I'm going to do a negation of that, I'm going to do not P in my next column. So looking at this, I know that P could be true or P could be false. So therefore, if I'm going to try and figure out what not P is, I'm going to look here and I'm going to see that not P would be the opposite of true, which would be false, and not P would be the opposite of false on this row, which would make it true. So not P is the opposite of the truth values for P. Looking at conjunctions. So I'm going to have two statements this time. I'm going to have statement P and statement Q. So my final column is going to be what I want to end up with, and that is P and Q. I know that it's and because of this symbol. A conjunction means and. So when I'm filling out the truth table, I want to make sure that I cover every situation between truths and falses for these two statements. So the way that I do that, I'm going to do it in a systematic way. I know that there are two statements right here, P and Q. If I want to figure out how many rows I need in my truth table, I'm going to take 2 and I'm going to raise it to the number of variables, which is 2. So 2 times 2 is 4. So there are 1, 2, 3, 4 rows in my table. 1, 2, 3, and 4. So the first thing I do is I take my column and I know that I need a true, and a false, and a false. My last variable or statement column will simply be true, false, true, false. Now this covers every possibility between truths and falses for these two statements. I can either have a true and a true and a false and a true, or a false and a false. So with a conjunction, please remember, right back here, we said that you need two truths for a conjunction to be true. Otherwise, it's false. So looking at this, I have my two truths. T and T is going to be true. T and F is going to be false. false and true is going to be false because you need two trues, and false would be equal to false. So basically, you have to know this table or be able to recreate this table knowing that two trues are needed to make a conjunction true. Moving to disjunctions. So in a disjunction, we're going to have two statements again, P and Q. So what I'm going to do is I'm going to figure out how many rows I need. So I have 2, and I'm going to raise it to the number of variables, which is 2. 2 times 2 is 4. So I have 1, 2, 3, 4 rows. So I'm going to take 4, divide it by 2, and that's going to be the number of true rows that I have and the number of false rows I have. So 4 divided by 2 is 2. So 2 of my rows are going to be true, and then 2 of my rows are going to be false. So I put true, true, false, and false. Now, I know that my second variable row or my second statement row is simply going to alternate true, false, true, false. So it's going to be T, F, T, and F. So now that I have every single situation that can happen true and false between two variables, I'm now going to figure out, calculate what the truth value of each statement or each row is. So if I have true or true, I know this is going to be true because it only takes one true in order to end up with a true as my answer. So I have true or false, and that's going to be equal to true because it only takes one T to make a true. False or true, once again, because of this one T, my answer is going to be true. And then we have false or false. Now, if we're looking at this, there are no trues, so it has to be false. So notice, here we have 3 trues and 1 false. Here we have 3 falses and 1 true for our conjunction. Again, I can't emphasize this enough right here. 2 trues for a conjunction to be true, 1 true for a disjunction to be true. 2 trues, 1 true. In a conjunction, you need 2 trues. In a disjunction, you only need 1 true. Now let's work on a problem together. The problem reads, construct a truth table for the following compound statement. P and, parentheses, not Q or R, end of parentheses. Now, we're going to have to go through this step by step, but one of the first things we look at and the questions we ask is, how many variables are there? How many statements, different statements are present in this problem? Well, we have a P, we have a Q, and we have an R. Don't worry that it's a not Q. It still starts out as a Q. We have to do Q first before we negate it and do not Q. So how many variables are that? There's 3. So to figure out how many rows we're going to need in our table, I'm going to take and I'm going to raise 2 to the 3rd power. Now that is 2 times 2 times 2, which is 2 times 2 is 4 times 2 is 8. So we need 8 rows in our table. So I want to make sure that I have my 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. Now, we're going to start out with all trues, and then we're going to go to all falses. We're not going to mix them up on that first row with that first variable. And to figure out how many trues we're going to use, we need to make sure that we know how many rows. There are 8 rows. We're going to cut 8 in half. So 8 divided by 2 is 4. So we're going to have 4 trues and 4 falses. Now, on that second variable, which is right here, our Q's, what I'm going to do is I'm going to cut this in half. So I know that I have 4 trues. So I'm going to start out with 2 trues and then do 2 falses, go 2 more trues and 2 more falses. My third variable over here, my R, is simply going to be TF, 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 TF. When you are doing a truth table, you're first going to approach the assigning of trues and falses based upon the system that we just covered. Let me go over it again. You take your number of variables, you put 2 to that power, so in this case it's 2 to the third power, which is equal to 8. So I end up having 8 rows. What I'm going to do next is I'm going to divide that 8 by 2. Everything above is going to be trues, everything below is going to be falses. So then half of 4, the number of trues and the number of falses that we have, so 4 and 4 is 2. So my next variable is going to be 2 trues, 2 falses, 2 trues, 2 falses, and then my final variable is just going to be TF, 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 and TF. Now we have 3 columns left. If you look here, we have our not Q column right here. We have our not Q or R column, which is right here. And we have our final column, which is what they want us to discover, P and the quantity not Q or R. So now we need to fill in these 3 columns. So the first thing we're going to do is we're going to do the not Q. And it's so simple when you're doing a not something, you're going to do the opposite. We look at Q, and I know that Q is true here, so this has to be a false. True here, this must be false. If this is false, not false would be true. If this is false, not false would be true. This is going to be false. This is going to be false. This is going to be true. And this is going to be true. So if I write those in, what I get is false, false, true, true, false, false, true, and true. Similar to PEMDAS, we do what's in parentheses or grouping symbols first. So here we have our not Q or R. So I need to figure out what is the truth value of that compound statement. So the way I do that is I look at this column here and I look at this column here. Notice it's the not Q and the R columns, all right? So what I need to do is I need to go F or T, F or F, T or T, T or F, F or T, F or F, T or T, T or F. And where did I get that from? I'm just substituting in the truth values for the statements. So if I have F or T, I know that it only takes one true to make an or statement true. So this has to be true. An F and an F, or an F or F, would make this a false statement. A T or a T would be a true statement. A T or an F would be true. An F or a T would be true. F or F would be false. T or T would be true. And T or F would be true. And notice the only 2 falses we have are when the not Q and the R are false. So we have one here and we have one here. All the others are true. Now, Where we go from here is we're going to take this column right here, and what we're going to do is we're going to combine it with the truth value from this column. So I'm going to take my P and my not Q or R. And the way I do that, I'm going to actually write what those truth values are. Because notice, with all these rows in between, sometimes it can get a little confusing. So what I'm going to do is, to make my life a little bit easier, I'm going to erase the yellow marks here, and then I'm just going to highlight this column and this column, because these are the two that I'm using. And that way my eyes are focused on the two yellow columns. So I'm going to simply write T or T. T, it's actually an and. T and T, T and F, T and T, T and T, F and T, F and F, F and T, and F and T. So I just want to make sure that I copied everything correctly. So I have a T and I have another T, we're good here. T and F, good there. T and T, both there. T and T, good there. F and T, good with that. F and F, we're good here. F and T, we're good here. F and T, we're good here. Now, you need to recognize that this is a conjunction. How many trues does it take to make a conjunction true? It takes two trues. If you only have one true and you have an F, it's false. So what I'm going to do is I'm looking at this and I'm going, okay. So a true and a true would be true. A T and an F would be false. A T and a T would be true. A T and a T would be true. An F and T, that gives us a false. This gives us a false. This gives us a false. And this gives us a false. So notice, we have three trues in these rows. So we have a true here, here, and here. All the others are false. Now, pause the video and go through in your head what we just did. Follow through with the process in regard to how many rows, how we do trues and falses, how we use conjunctions and disjunctions, how we break down a complex problem like the one you see here, right here, how we break this down into steps or stages that make solving it so much easier. See if you understand it, and if you have any questions, please do not hesitate to ask. Now it's your turn to take the lead. Let's see how you can apply the concepts we just learned. Negation, conjunction, disjunctions, and building truth tables to solve this compound statement. So the compound statement is parentheses P and not R, or not S or Q. So take a look at the compound statement, and in your head, I want you to start beginning to build the table that you're going to need. Your first question should be, how many different statements or how many variables are used? Well, we have 1, we have 2, we have 3, and we have 4. So we have 4 different variables, and here's our variables. And so what we're going to do is we're going to take that 4 and we're going to raise 2 to the 4th power. and that's going to tell us how many rows we're going to need in our table. So we're going to need 16 rows in this table. Now, 8 of those rows are going to be trues, and 8 of those rows are going to be falses. So I drew a little mini table out here so you could just see it. So we're going to have 8 trues and 8 falses for my P's. My Q's, if I cut this 8 in half, I get 4. So notice that this adds up to 16. And so if I have 4 T's, 4 F's, 4 T's, and 4 F's, if I add those rows up, I get 16 as well. Now what we're going to do is we're going to cut these 4 T's in half, and that's going to give me 2 T's and 2 F's. So I get 2 T's, 2 F's, 2 T's, 2 F's, 2 T's, 2 F's, 2 T's, 2 F's. Now, if I add this up, I end up with 2 plus 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 2 is 16. Notice that this equals 16, this equals 16, and this equals 16 rows. And so my next column is going to be my last variable. And remember, your last variable is always just going to be TF, TF, TF. You're going to alternate your T's and your F's. So we have 16 rows here. So 16, 16, 16, and 16. Now, in those 16 rows, the trues and the falses for each one of those statements, every possibility of a true and false combination is covered. We make sure of it by doing this process and this procedure. Now look at what this problem is asking. Once you know how to build the table, right here, they have a specific question. They're asking what values of P, Q, R, and S will give a false compound statement. So they want at the end, so when you build your table with all of the columns and you finally get over here, they want to know what values of all these variables is going to give me a false compound statement. Please remember to show all of your work in your notebook. And if you have any questions or if you have any issues, please ask for help. You may check your answers on the next slide. Now, please pause the video and complete your work. And when you're finished, press play to continue. Now, here's the answer to the problem, okay? So here are our 16 rows. Now remember, what we're looking for is what ultimately ends up as a false statement in that last column. Please pause the video and check your answers, and when you're finished, press play to continue. The answer would be, in order to end up with an F in that final column, I would need to have a true, a false, a true, and a true for my P, Q, R, and S. Or a false, a false, a false, and a true. Again, check your table. Make sure that your table looks like my table, that the T's and the F's are in the right places, that you've done your negations correctly, you've done your conjunctions, you've done your disjunctions correctly. This is it for today's video, guys. We did some great work today. If something does not make sense, that is your cue to ask questions. In fact, it's your responsibility to ask questions. You can come to me, or you can talk with your classmates or your shoulder partners, or even try AI for a step-by-step explanation. Remember that we're a team here, and we're all here to help one another succeed. You learn best by breaking down complex concepts into smaller, more manageable skills. And that's exactly what we did in today's video. You are turning your practice time into your superpower. Now, you know that I believe in you, and you know that I know you can do this. You are working your way to success, learning one skill at a time. I want you to have a great day, and thanks for working with me.